Hello, I'm Yasir. Today I will apply shooting method to boundary value problem. Shooting method based on second order Runge-Kutta method. So for second order Runge-Kutta method, the formula which I will use, I will bring here. So I will use this formula, and on the problem, for the problem, I have a paper. It's not mine paper. It's not my paper, but mm, it contains an equation, the third order differential equation 19. So I will pick this equation. So this paper is already already published in the journal International Journal of Modern Mechanics. So I will try to solve this problem. So for this, the first stage of Runge-Kutta method. No, first, not first stage. First, I will convert the system into system of first order equation. So I will use f prime is equal to g, and f double prime is equal to, which is g prime, and this is equal to h. And now this equation will be can written as m. F prime is g, so I will write g square minus 1 minus m plus 1 over 2 f, and then f, not f double prime. F double prime would be h. No, it's just h. And then I bring this term, the last term, I bring on the right hand side. So that would be that can be written as mu of x and h prime of x, because f triple prime would be h prime. So now the last equation can be written in this form: h prime is equal to 1 over mu of x, and then m g square minus 1 minus m plus 1 over 2 fh. Now I will start with the first stage of the Runge-Kutta method, this one. Here h means step length, but here h is not the step length. H is just g prime or a double prime. So in this h, I will, instead of this h, I will use delta t. So V11 is equal to delta t, and then the first equation g. So I write gn, and then V12, V12 g delta t and hl, and then V13. V13 is 1 over mu delta t over mu, and then m g square, evaluated at n grid point, minus m plus 1 divided by 2 fn hl, and bracket close. Now for the second stage, I will use V21, and here I will have delta t, and then it's a yn plus half V1, so previous state. So gn plus half V12. So G it will be V12. and then V22. V22 is delta T, and that would be the H of n plus half V13, and then V23. V23 is equal to delta T over mu or mu of x. It's a m, then Gn plus half V12 whole square minus 1 minus m plus 1 divided by 2, and this would be a Fn plus half. For F, equation would be V11 plus stage would be V11, and then for H1, for Hn, so Hn plus half V13. And now the solution will be calculated at the next time level or the next grid point. So that would be Fn plus 1 is equal to Fn plus. So here, according to the formula, it is the previous, the last stage, V2. So here the last stage would be a V2 one. And then for Gn plus 1, for Gn plus 1, it would be a Gn plus V22. And for Hn plus 1 is Hn plus V23. So, so that's Runge-Kutta 4. I have to apply the Runge-Kutta 2. So I so here so V11 V11 is equal to dt and then G of n. Then V12 is equal to dt or delta t H of n. And then V13 is equal to dt over mu and then m into G of n whole square minus 1 minus m plus 1 divided by 2, and then Fn H of n. So that was the first stage. And for the second stage, I will use G of n plus of V12. And this would be a H of n plus of V13. And here this would be G of n plus of V12 whole square. And then for Fn, I will add V11. Then for Hn, we have V13. Then The last here I would have. So now this step would be a 2-1, 2-1, 2-2, 2-3. So here the first stage is the latest the first equation of the last stage 2-1, V2, V2-1, and then V2-2, and then V2-3. Now if I run this, so let's see what happens. So where is the problem? So I will start with the smaller domain and then see. For this thing is I. This is Fn plus half V11, then HFN plus. So it's not converting even on the small domain. So I decrease it. Yeah, it's approximately there. Now it's 4.7. So I will do the latest guess for the missing initial condition. And I will run it on 1.5. Yeah, it's working. I can't tell you. Perhaps I will use the latest one. And see with the tool. And I increase the tool, increase the tool. If I run this, oh, direction. So here, yeah, it's working on two. So I save these files. I have to check that the solution is correct or not. I will compare with the BP4C solver. For BP4C, I have to decrease the domain 0 to 3. The same problem solved by BP4C. For checking the solution is correct or not for verification. So I applied the BP4C as well. Then let's see what happens. So that's save this. explore. I know I love the shooting. I think I will shoot them. Okay, yes. I have to compare the solutions. So this is the solution. So what I will do. So both are matching approximately. So the non-solution is correct. So that was the solution obtained by the Runge-Kutta second order method. Uh, so it is applied within the shooting method. Actually, it's a shooting method, but the differential equation are solved by the Runge-Kutta method, and the equation are solved by the zero solver, MATLAB solver. I end this video. Love is bye.